Okay, so the solution now to number 7, part A. So we're given this equation, let's just write it down, x squared plus k times x, where k is a constant, plus all of k plus 3, and we're told it's equal to 0. Okay, now this quadratic apparently has different real roots, and we've got to prove an inequality here in part A. What this question revolves around is your knowledge of roots of a quadratic equation. Just to take you back for a moment, when you solve any quadratic equation, you would normally use the formula, the quadratic formula. Do you remember? X equals minus b plus or minus square root of b squared minus 4ac. Okay, all divided by 2 times a. Now it's this value inside the square root, often referred to as the discriminant. That's b squared minus 4ac. That is the value that always controls how many roots that you have. Now we're going to have different roots for this particular question. So that would mean that this quantity that we're square rooting has to be greater than 0, because if you square root anything greater than 0, you'll always get 2 answers. Okay, so it relies on that fact that b squared minus 4ac is a positive number. So to introduce this problem, or this answer I should say, what I'm going to say is that for different roots, okay, b squared minus 4ac has to be greater than 0. That sets me up with my inequality now. So therefore, what I get is b is the k, so that would be k squared minus 4 times the a value, which is the 1 in front of the x squared, times c. C is this constant term on the end here, so that's times k plus 3, and that has to be greater than 0. So therefore, if we just tidy this up by expanding it out, we would get k squared, 4 times 1 is 4, negative 4 times k is negative 4k, and then negative 4 times plus 3 is negative 12, and that would be greater than 0. Okay, so we've been able to show that inequality, that quadratic inequality. Now we go on to solve this quadratic inequality to find the possible set of values of k. Now to solve a quadratic inequality, what we need to do is factorize it first of all. I'm assuming it factorizes, by the way. Looking at part B, it doesn't seem to give any indication that k would be in surds or anything like that. So I'm assuming it's going to factorize. So working from that point of view, we'll just copy it down again. Okay, therefore factorize it, greater than 0, k here, 2 values multiplied together to give negative 12. What about let's say 6 and 2, 6 and 2 would do. If I put a minus there, I get minus 6k, plus here I get plus 2k, minus 6k and 2k makes minus 4k. Alright? Now when we get to this stage, you see so many students, or I see so many students anyway, write down things like k minus 6 must be greater than 0 or k plus 2 must be greater than 0. Don't ever do that, okay? Don't ever do that. You'll always go wrong. What we need to do is find the critical values. So what I'll do is I'll just write down here critical values. These are the values of k which would make this equation equal to 0. So in other words, if it did equal 0, we could say that k minus 6 would equal 0, or k plus 2 would equal 0. And therefore that would lead on to k equals 6 or k equals minus 2. These are the critical values. Now why have I done this? Well, the next stage is that we need to draw a graph. Okay, so what we're going to do is just over to the right here, we'll draw axes. We'll have a y-axis, and what I'm going to do is draw a sketch graph of y equals, let's just put this up here, and we'll do it in a different colour as well. We'll have the graph then of y equals k squared minus 4k minus 12, k squared minus 4k minus 12. And we know that this equation here is exactly the same as me writing k minus 6 in brackets multiplied by k plus 2. Okay, as we have here. Now these critical values are the values that the graph would cross the k-axis. By the way, I haven't marked that axis in. It's not the x-axis, it's the k-axis in this particular problem. And so when k equals 6 and k equals minus 2, these are the values where the graph would cross the k-axis. So I marked them in here. It's not drawn to scale. Just put that there like so, minus 2 and 6. And so what I'm going to do is sketch the graph. Now this is a quadratic, a positive quadratic graph, so positive quadratics, positive k squared that is, are U-shaped. So the graph is going to come down through the negative 2, cross the y-axis and then back up through the 6. Now what I'm looking for is that my y values, that's over here, the brackets here represent y, that the y values turn out to be greater than 0. Y is greater than 0. And I've got to look for what values of k make y come out greater than 0. Well, y is greater than 0 when you're on this branch of the curve and when you're on this branch of the curve. It's above the k-axis, so y is positive here and here. Y is positive then for values of k that are greater than 6 and values of k which are less than negative 2. I'll shade that portion in. There you go, there and there. Okay, so what we need in order to get this quantity, which I'm calling y, to be greater than 0, we need to have values of k more than 6 or less than minus 2. So what I'm going to do now to finish the problem is just say that from the graph, okay, what I can see is that the value of k then would be less than minus 2, or quite separately k could be greater than 6. And that is the solution, that is the range of values of k which would make this graph have, or shall I say make the equation up here have two different roots. Okay? By the way, if you are having problems with quadratic inequalities, I've produced a simple short video free to look at on solving quadratic inequalities, which does a similar example to this kind of one up here. Okay, so just go to our site and have a look under our free tutorials, quadratic inequalities, and you should find a video there that gives you another demonstration of this. Okay.